Hey, good day, everyone, and welcome to week number 7. And as Vicky said in the comments, you are some dedicated people to still be here after listening to me for the last 6 weeks, and you decided to come back for some more. So again, thank you very much for being here. And today we're actually going to start talking about the mechanics of how Bind does the signing and how we make this data available. We've been through a lot of the behind the scenes stuff, and now we're going to start seeing some things of how to actually make it work. So welcome aboard, and again, thank you for being here. So let me go back, and I am gonna do a little bit of review and a little bit of review of the specific pieces that we're going to be dealing with today. And first of all, we're going to talk about the key material and the fact that when you're doing a signing of a DNSSEC-signzone and you do it in the way that it was originally recommended in the second in DNSSEC biz, you end up with two keys. You end up with a ZSK and a KSK. And what this really comes down to is that when non-cryptographers create standards that involve cryptography, sometimes bad science is used and sometimes bad results occur. And I'm not going to necessarily say that this was actually bad science, but one of the reasons that I was always told and that I always taught why we had a split key, why we had a separate zone signing key and a key signing key, was that when you used a key more to create signatures, the weaker it became. So the idea was that you would have a zone signing key that was separate from the key signing key. The zone signing key would be used to sign all of the authoritative data in a DNSSEC-signzone. So that means that all of the A records, the quad A records, the SOA record, and all of the other pieces in there would be signed using the ZSK. And again, zone signing key used to sign the data in the zone. Now, the key signing key was specifically used to sign the DNS key resource record set. So there would be a DNS key record set, obviously, containing all of the keying information, the public portions of the keys, and that specific DNS key resource record set would be signed using the key signing key, the KSK. Now, the fact that these were split allowed you to change the keying material of the zone signing key without having to notify the parent. So this made key rollover simpler because anytime that you wanted to change the zone signing key, you didn't need to change, remember the delegation signing record, the DS record that was in the parent? You didn't have to change that record when you created a new zone signing key. Well, the reason that you wanted to be able to create a new zone signing key was that any time you created a new record or deleted an old record, basically any time that you modified the zone information, you were going to be using the zone signing key to create a new signature on whatever information had been modified. And in addition, obviously, any time that the resource record signatures would expire, because remember the RR-SIGs have that expiration date in the resource record, anytime that expiration date were coming around, you had to recreate the signatures. So what I was always told was that if you were re-signing or if you were using a key over and over again with known plain text and known output ciphertext, then that key was becoming weaker every time it was used. Well, I've now been told by other people that that's not necessarily the case. So not even a really big deal that you don't need to change these keys as often, but also that a zone signing key and a key signing key can actually be now a single key, and that is a CSK, a combined signing key. Now, I'm not going to talk too much about that because that's actually a standard that is actually quite new, but I am going to talk about the use of the ZSK and the KSK. So the common practice currently is to use multiple key pairs. You're going to have a ZSK or zone signing key, again, that signs all the authoritative data in the zone, and a key signing key, the KSK, that signs specifically the DNS key resource record set. Now you may notice, and it depends on some configuration options and some versions of bind, that your DNS key resource records may be signed with both the ZSK and the KSK, or possibly only the KSK. The only real issue here is that obviously if you're signing it with both the ZSK and the KSK, then you are going to have multiple signatures on that resource record set. So the DNS key resource record set may have a single signature with the KSK, or it may have multiple signatures from the KSK and the ZSK. So the KSK signs the DNS key resource record set, and it always has an odd flag number. So if you remember, we had the flags field, and it's a 257 if it is a key signing key. So when the key signing key is rolled, when you put in a new key signing key, when you change it, the DS record in the parent has to be updated. So anytime that you do a key rollover, and we'll talk about key rollovers next week, I think next week or week after, but right now we're just talking about the initial signing, but you will need to change the DS record in the parent anytime you update the KSK. So again, the thought was that the key signing key should be created with a large key size to be robust against brute force attacks. Now, this line comes from a time period that was before the use of the elliptical curve algorithms, which do not have a specified key size. So some of the algorithms that we're going to be using today and that you will see in some of the examples do not actually have a specified key size. The KSK was expected to have a long lifetime. You were going to sign your zone. You were going to create, obviously create these keys. You were going to sign the zone with the ZSK, the KSK used to sign the DNS key resource records, the DS record inserted into the parent, and then the key signing key and the DS record were not going to be changed for a long period. Now the ZSK, on the other hand, signs all of the authoritative data in the zone. So now a little bit of trivia here. The non-authoritative data in a zone is going to be any glue records. So in this case, in the case of a delegation where you are delegating to a zone that has the associated name servers within the zone to which you're delegating, you are not going to, in your zone, create signatures on the glue records that are going to be appearing in the child as authoritative data, because that is non-authoritative data in your zone. So the ZSK has an even flag number. So in this case, it is going to be a 256. And it is able to be rolled or changed without the need to change the DS record in the parent. So the ZSK only appears in the child. It has no relationship to the DS record in the parent because, again, the DS record is the hash of the key signing key. So you can make a change to your ZSK as often as you want, allowing it to have a shorter lifetime, and it can be rolled more often with less interference between you and the parent. Now, we go back again to the chain of trust. The chain of trust is a chain that links from the root or some other signed starting point into a signed zone, with each chain link validating the one below it. The thing that allows this validation to occur is the DS record that occurs in the parent, and it is used to identify the child's public key, the zone's public key, and specifically the key signing key. The child's DNS key resource record set is self-signed by that zone's key signing key. So now let's talk about how we get all of that data how we go about inserting it, how we go about actually creating the signatures and making all of this happen. Now, I will tell you that this is going to be doing it the hard way. If you're familiar with Rube Goldberg, this is definitely, as far as today goes, the Rube Goldberg way of doing DNSSEC signing. The new the KASP tool, the key and signature policy tool that is built into the new version of Bind is going to be the way that you will want to deploy DNSSEC. But if you're doing it with any of the older tools, this will give you, and also this will tell you what's actually happening behind the covers. Now, doing DNSSEC deployment, I don't do it this way anymore because this is hard, but you do need to understand it before you can actually do it the easy way. So the steps to signing a zone. First of all, we're going to enable DNSSEC in Bind. Now, this is one of those things that there is an option that is in the options clause in the configuration that you're going to be able to turn this on and off, and I'll talk about each of these steps as we go through them. The second thing that you're going to do is you are going to generate the key pairs for the zone. You're going to specify the algorithm, and then you are going to create the zone signing key and the key signing key. You're then going to take those DNS key resource records and put them into the zone file itself. Once that is done, you're able to sign the zone. You're going to go in and you're going to create the the RRSIG, the resource record signatures on all of the authoritative data. You're then going to tell Bind to actually begin serving that signed data. Now, at this point, you are going to be able to see the DNS key resource record set. You're going to be able to see the RRSIGs on all of your other records. You're going to see NSEC or NSEC3 records in your zone, but it isn't going to be required that all of the other people in the world actually do validation on your data. Because first thing you want to do before you make people do validation is do testing. Test, test, test. It's going to be very, very important to make sure that everything is in the right place and working correctly before you do step number 7, which is to send the key set or the DS record to your parent's zone administrators. Once the administrator of the parent zone or whoever it is that maintains it puts those DS records into the parent zone, if you have broken DNSSEC data in your zone, you're going to have some major problems, because at that point, everybody out in the world is going to recognize that since there is a DS record in your zone or in the parent zone for your zone, then they are going to need to start doing validation. If you have bad data in your zone at this point, you may have a really bad day. You wait for the zone record, for the DS records to appear. And once this occurs, once step number 8 occurs, you're up and running with DNSSEC. And then obviously you continue to do testing. You want to make sure that you're testing not only that your zone is functional, but also that somebody that does a query for, an NX domain or a no data response actually gets back a negative result. And you're going to also want to make sure that your signatures are maintained and don't ever expire. Because again, expiring signatures is a bad thing. So now let's go through each of those steps. First thing we're going to do is we're going to actually enable DNSSEC in Bind. So in your options section, you're going to want to put in a DNSSEC enable yes statement. Now, as of Bind 9.15, this DNSSEC enable isn't even an option anymore. I mean, I think it's still there, but it isn't actually used because it is always set to true. Now, I said that that was in 9.15, but I'll tell you a secret. The secret is that DNSSEC enable yes was always yes. And I'll explain why. And actually, I think I may have already explained why, because when we were talking about configuring Bind to do validation, you remember that you actually had to go in and create a trust anchor. So you had to put in a trust anchor into your Bind configuration. And if you did that, then you obviously wanted bind to start doing validation. And this DNSSEC enable, yes, does actually something different than what I was just talking about. This actually says that if a zone is signed, if there are resource record signatures in the zone, and a client out in the world does a query that says, that has the DO bit, remember the DNSSEC OK bit, if that bit is set, then the upstream server is going to send back the signatures as well as the data. So they're going to get back the data and the signature. This DNSSEC enable yes actually does that. So this setting was, again, as I said previously, always yes from the very first day that this was an option. And that was set for yes because we made the assumption that if you as an administrator went to all of the trouble to create the keys, to put the keys into the zone, to sign the zone, therefore making the signatures visible, and then to actually start serving that data, make it visible to bind, then when a DO bit came in, you actually wanted to respond to it with the DNSSEC data. So the only thing that this ever did was if you, for some reason, whatever that reason was, wanted to have a signed zone, so with the RR-SIGs in the zone, but you did not want that data to appear if somebody did a query with the DO bit set, then you could set DNSSEC enable to no, and bind would not respond. So DNSSEC enable yes, it was always yes, and as of 9.15, you can't say no. So now that we have that set, and obviously you need to do an RNDC reconfig to make that take place, but you don't need to make that take place because it is the default. You need to go around and make the keys, you generate the keys for all of the zones that you are going to be signing. So in this case, I am in a directory called KSK subdirectory new, and I run the command dnssec-keygen. Now, dnssec-keygen is obviously the utility that generates the DNSSEC keys. And we, at this point, are giving it two options. The first of the options is the -A and the algorithm name. So in this case, you can see we do a -A RSA SHA-256. So we are using the RSA SHA-256 algorithm to generate this specific zone signing key. And we also give it the name of the zone. So in this case, I was signing my own zone, cleg.com. This now goes off, it runs for a while. It tells me that it's generating the key pair. It gives me some dots and pluses as it goes through, and it does its complicated set of calculations to create the zone signing key. And it gives me the output of uppercase K, the name of the zone, plus 008. And you'll notice that 008, it says in one place, but then down at the bottom, it says key algorithm number 10. I apologize, that should be 10. I'm sorry, it should be 8 in the text at the bottom because RSA SHA-256 is algorithm 8. And so and then the last thing there is the plus 11415, and that is the key ID of this specific zone signing key with algorithm 8 for this specific zone, cleg.com. So we now have generated a zone signing key for cleg.com. We have not made any modifications to the zone data. We have not inserted this key. We have not made bind aware of anything about DNSSEC. We've just run this little application to create a zone signing key. This doesn't need anything other than what is shown on the command line. It does not go out and look at the zone data. All it's doing is creating a specific algorithm key for a specific zone name. And you'll notice that this creates a zone signing key by default. So if you don't tell it to generate some other type of a key, we get a ZSK. So now I need to do the same thing to generate a key signing key, to generate the KSK for the same zone. Again, I'm going to run DNSSEC keygen -F KSK. Now this time I am specifically telling DNSSEC keygen that I want to create a key signing key. It's going to go out and it is automatically going to use, or it's automatically going to create the flag field of the 257. I am telling it an algorithm of RSA SHA-256. And again, I'm specifying the same zone name as I specified previously because I am creating a zone signing key and a key signing key for clegg.com. The output is the same, or the same information. We have an uppercase K and the name of the zone. We have a plus and the algorithm number. And again, I have a mismatch on the slide and I apologize greatly. Then I have the key ID, which is again, the semi-random number that matches this key with this algorithm and this key and that zone name with what we're going to use it for in the next couple of steps. So now we have a zone signing key and a key signing key. By default, this application, the DNSSEC keygen, creates the keying material in the directory where the application is run. So whatever directory, when I ran this in the CleggZone /new directory, these keys are going to appear in this directory. There is an option that you can give DNSSEC keygen that will tell it the directory to put the files into if you want to do automation. That's absolutely fine, but this was run from the command line and it's going to drop the keying material into the directory where it was run. So now if I do an ls-l or al, you'll see here that the zone data is there, the clegg.com zone of all 466 bytes of it. We see that there are two sets of keying material. So there is a key for 11.415 and a key for 13.846. Now looking at these, I really can't tell which key is which. Which one of these is the key signing key and which one is the zone signing key? So I'm actually gonna, unfortunately today is the first day I've actually looked at the chat as it's been going. So I'm gonna have to close that because I looked at that one. I'm not gonna answer that right now. Anyway, we'll get back to that. So what we see here is the information. Now, which of these key IDs goes with the key signing key and which of these key IDs goes with the zone signing key? Well, we can find that out by looking in the keying material. So if I just do a cat of star.key, what I discover is that in the keying material or in the key file, there are comments, and you'll notice that these are preceded with a semicolon. So they are comments just like in a zone file, because I'll give away a secret. We're going to actually put some of this data into the zone file. Probably not the key. We're probably going to put the, or actually the key, we're going to use the key. We're not going to put the private portion in. But you'll see that we look at the first one and we see that this is a zone signing key, key ID 11415 for clegg.com. And the second one says this is a key signing key, key ID 13846 for clegg.com. So it's very easy to write a script or use your eyeballs and see which of these is a key signing key and which of these is a zone signing key. Very easy to write a script that just does a grep in star.key, looking specifically for zone signing or key signing, and then pull out the next field and get the key IDs. And again, automation with this is quite easy. Now, the use of the comments in the keying material did not occur until I want to say like by 9.11, no, 9.10. Anyway, very early versions, ones that you shouldn't be using anymore, those versions of DNSSEC keygen did not put these comments in. So if you don't see these comments, you really, really, really need to upgrade your installation of bind. The other keying material all worked, and it worked fine, but it didn't have these comments. So you started having to look for 256s and 257s. So you'll notice that where this one says it is a zone signing key, key ID 11415. If you look down a couple of lines, you'll see clegg.com DNS key 256. We know that this is a zone signing key because of the 256. We know that the next one is a key signing key because in the DNS key record, we see the 257. Now, the unsigned zone. Here is the unsigned zone data. It's a very, very simple zone file, literally with an SOA record, an NS record associated, a 2 record or 3 record, 4 records at clegg.com, 2 records at allen.clegg.com, and about as simple as you can get. What I'm going to do now is add the DNS keys to that zone file. So if you remember when I did the ls-al, there was a .key file for each and a .private file for each. You don't want to put the private data into your zone file because that's the secrety portion of the key that you're going to use to create the signatures. Don't put the private portion of the key into your zone. Now, the nice thing is it's not actually going to work if you do a cat of star.private onto the end of your zone, because the format of the private portion of the key is different from the zone file format that you'll see in the key file and in the zone data itself. So if you accidentally do it, you're not going to be able to serve the zone because the zone is now going to be invalid. So I did a tail -12 on clegg.com, and we see that now after that final record of allen.clegg.com quad A record, we now see all of the data, including the comments of the ZSK and the KSK in the zone file. So now we have no signatures in the zone because we haven't toll bind, we haven't done anything to generate signatures, but we now have all of the zone data and the associated keying material, the public portions that will be used to validate the data once we get the signatures in place and all of the other bits. So now what we're going to do is we're going to run the dnssec-signzone application. And what this is going to do is it takes the name of the zone, it looks in the current directory, and again, there is an option on DNSSEC-signzone that you can tell it where to look for keying material. But in this case, we're running it the simplest way possible. It looks in the current directory. It looks in the key data that it finds, the .key or the .private, and finds the keys that are currently active. Now, we'll talk about the active and inactive keys when we talk about key rollover, but if you look at the keying data, there are dates in there, not only for the date of the creation of the key, but also the time that it is to be active, the time that it is to be expired, and a couple of other timing parameters as well. So DNSSEC-signzone is going to go out and it's going to look and it's going to find all of the active keys for the given zone, and it's going to actually go in and create the signatures as needed. So I run the command dnssec-signzone, clegg.com. I get the output of DNSSEC-signzone, warning, using RFC 1035. That means that there was no $TTL statement at the top of the zone file. So it used the one that was in, or used the expiry time as specified in the SOA record. It verifies the zone using the algorithm RSA SHA-256. It noticed, or it discovered, that we were using algorithm number 8 in the keying material. So it automatically says, okay, I need to create the signatures for RSA SHA-256. The zone was then fully signed with algorithm SHA-256, 1 key signing key, 1 zone signing key active. There were no keys on standby and no keys revoked. We'll talk about those standby and revoked keys as we talk about the key rollover in a couple of weeks. So DNSSEC-signzone does have a couple of other options. if you're familiar with the SOA record, you know that one of the fields in the SOA record is the serial number for the zone. Well, a lot of people, you know, it's just a number, so it can be, you know, anything. You can, as long as it continually moves forward, as long as whatever your current serial number is greater than the one that you were just using, and the one that you're going to be deploying now is greater than the one that is there now, then all is good with the world. One of the things we discovered was that a lot of people have different formats or different ways of incrementing the serial number than what well, there are many ways to do it, so we decided there would be other ways that we would allow it to be done. So the -n increment takes the serial number and adds 1 to it, because obviously the newly signed zone is different from the unsigned zone. So we have to increment the serial number to make sure that the primary, when it loads it, the secondaries all pull the new data. There are other options to the -N, which are keep, which is don't change the serial number, and also Unix time. And this one is one that's kind of neat. And what this does is it uses the serial number of the current date, the current Unix time, the epoch date, the number of seconds since January 1st of 1970 as the serial number. I really like that one because you're guaranteed to have it always moving forward. And unless you regenerate your zone file more than once a second, it's always going to be unique, and it's always, as I said, it's always going to move forward. The signatures, again, they have an inception date and they have an expiration date. You can specify on the DNSSEC-signzone command line a -E and then a time, and it's by default an expiration in seconds of the given signatures. So you can say, I want these signatures to be valid for a day by specifying 86,400. You can have it specify a week by specifying however many seconds are in a week. I recommend that you not change the default. And of course I say that and I don't remember what the default is at this moment. I want to say that it's 2 weeks. But anyway, you don't need to specify an expiration date. And as long as you run DNSSEC-signzone, again, on the signed zone data, the signatures will be updated as they are needed to be updated. You know, if a signature is within the last third of its expiration date, it will automatically be regenerated if DNSSEC-signzone discovers that there are signatures in the existing zone data. There's also a -J option, which introduces a jitter into the expiration dates. One of the problems that you're going to have if you have a very large zone file and you specify and you do manual zone signing, all of your signatures will expire at the exact same time. And that's not necessarily a good thing because, number one, it requires you to regenerate all of the signatures on the entire zone every time. But it also means that all of your secondary servers are going to need to take the zone transfer of the entire zone plus all of the new signatures every time that you do that re-signing. Obviously, that's going to make incremental zone transfers significantly less than useful. And so you really don't want to have all of your signatures expire at once. If you're using a dynamic zone, if you're using the KASP tool, then the signatures are going to automatically get a bit of randomization put into them because a signature is going to be created, for example, on a dynamic zone. You are going to get a new signature on the specific resource record that is being added to the zone when it is added. So immediately that piece of information or that signature is not going to be in lockstep with all of the other signatures in your zone. So again, this is something that way back in the day when we did manual zone signing, it was a good idea to introduce jitter. Now we're going to look at the actual signed zone. When you ran DNSSEC-signzone, it did not overwrite your existing data. It actually created a new zone file called whatever the name of the zone was, .signed. So in this case, we have the output of the DNSSEC-signzone being the file cleg.com.signed. So we do a cat on this file, and at the beginning of it, we see that the file was written on this specific date. We see the version of DNSSEC-signzone that was used to sign the zone, and then we see the information, the SOA record, and sure enough, there is the RR-SIG, the signature on the SOA record that did not exist in the non-signed zone. So congratulations, you have now created a signed zone that has signatures in it, in addition to the keying material and obviously the already existing resource records that were in the zone. So now we need to go out and tell bind to actually start serving that signed data. So what we'll do is we're going to go in and we're going to change the zone stanza so that instead of having it use the cleg.com file, we're now going to use cleg.com.signed. Now you could, if you wanted to, go in and rename or move the cleg.com.signed right over top of the cleg.com data. That actually is one of the mechanisms that I used back in the day. Then when you re-sign the zone, when you rerun that DNSSEC-signzone on the name of the zone, DNSSEC-signzone reads the signed zone data. Since it finds that the data in the zone is already signed, it refreshes the signatures that need to be refreshed and leaves the other ones intact, and it creates again a new .signed file, which to make active, you would move it back to the name, the original name, cleg.com, and then do an RNDC reconfig or RNDC reload on the zone name, and it would automatically pick up the newly signed zone file. So in this case, we're actually going to point it to a different file. We're going to point it to cleg.com.signed. And now when we do an RNDC reload of cleg.com or an RNDC reconfig, it is all automatically going to pick up that new signed data. When I do the RNDC reconfig and I look at the config or look at the log file, I see that at the bottom down there, we see cleg.com, the name of the zone, not the name of the zone file, because remember, it was reading from cleg.com.signed. The zone cleg.com in the internet class was loaded. It has serial number 12. And notice in the parentheses, it says that it is DNSSEC signed. Congratulations, this zone is now being served, DNSSEC signed, and then we get the final message that says the zone's loading were successful. So now we have reloaded the zone. Anyone doing a query against our name server for this specific zone, if they specify the plus DO, the DNSSEC OK bit, they're going to get back the data plus the associated signature with the data. So we're going to talk about testing. We're talking about it a little bit today, but we're going to talk about it a whole lot when we go into the DNSSEC debugging. But we're going to assume at this moment you're going to do some testing. Like I said, we'll explain exactly what that means in a little bit. At this point, you're going to, once you've done your testing and you're happy with the testing, and you know that that your zones are coming back with the information as wanted, you now are going to submit the DS set, the DS resource record set, to your upstream provider. So in this case, I'm going to send mail to the hostmaster at my registrar, and I'm going to send the subject line of please insert example.com DS record into the example zone. And again, they're actually going to insert it into COM, and it's going to show up as a DS record in COM for example.com, and it is going to be signed with the COM signature. Greetings, would you please create a DS record for my example.com and put it into your zone? I'm going to attach to that the dsset-cleg.com file, and once that is processed, I will now have a DS record in the parent. Now, where did this dsset-cleg.com come from? As I said last week, there is a utility that you can run called DNSSEC DS from key. But when you run dnssec-signzone manually, it's going to create this DNS key, the dset file, and it's going to contain the key, the hashing material that's going to be needed to be inserted by the parent. So this is what the contents of that file. If we cat the dsset-cleg.com, we see cleg.com, we see the DS record, we see the 13846. Now this should look familiar because it should be the key signing key key ID that was created, a couple of steps before when we generated the key signing key. Once you've done that, then your zone is ready to go. The procedure to get this DS record into the parent zone is going to differ from registrar to registrar. And because there isn't really a defined way to do this, it should be something that ensures authenticity, that is, authentication, and it ensures the integrity of the data. What you don't want to have happen is someone else other than your zone maintainers being able to insert or delete or modify the DS record in your zone. Back in the day, I had a zone in the .org TLD, and I literally provided them the DS record because it was before any of these procedures were in place. I literally sent an email that said, "Here is my DS record, please insert it into your zone." Now, they were able to validate that because my zone was signed and it had the DNS key resource records visible, obviously. So they were able to validate it, the DS record, by going to my zone, pulling, doing a dig of the DNS key resource records, finding the one that was the key signing key, then running the hash of that key signing key, and then comparing it to the DS record that I sent them. Not complicated, works very well, but you do want to make sure that not, any random person is able to modify or delete your DS record. And you do want to absolutely make sure that it is not modified in transit in any way. You really want the parent of your zone to do the checking to make sure that when you provide them a DS record, that the DNS key resource record is in your zone. They should do that for you. I'm not going to guarantee that they're going to, but they should. You now wait for the DS resource record in the parent zone. So in this case, I'm going to do a dig of cleg.com DS. And as you see there in the answer section, there is cleg.com DS record and that information. We see in the flags field, you see the AD bit that is authenticated data. So we know that that DS record is signed by the parent. So in this case, the .com zone signing key. That DS record, was the private portion of the COM zone signing key, was used to sign this record, and we know that it validates because of the AD bit. So in this case, congratulations, you now have a DS record in the parent. It matches up with the key signing key in the child, and you now have a chain of trust in place that we're able to validate all the way from at least COM and, pardon me, most likely all the way from the root. So what I'm able to do now is do a dig of cleg.com SOA record plus DNSSEC plus multi, and you'll see that I get the AD bit in the flags field. There's nothing actually here that actually shows the output of that was created by the plus DNSSEC, but this resource record, this SOA record, would have with it the RRSIG for the SOA record, and that would be the proof that that signature was there and that it was all working correctly. Now, The signaling of this in the message headers is done by the AD bit, which is the authenticated data bit, and the CD bit, which is the checking disabled bit. So these are the only two bits that were used in the DNS or in the DNS headers that were previously defined that are used for DNSSEC. Now the AD bit is returned when the upstream validating recursive server actually does validation on the data. And it can also be set in the outbound data if you want to only get back the AD bit and not all of the other signature data, but you still want to see that signature or that validation is occurring. The CD bit we'll talk about when we start talking about debugging DNSSEC. And that bit is used in the case where you have an upstream server, pardon me, the upstream server that is giving you back possibly a serve fail for a given zone, and you're thinking that that may be caused by DNSSEC and a failure to validate, then you're able to set the CD bit and force it to checking disabled on the upstream from the upstream server. So again, here in text is what I just said. The AD flag, a validating resolver is signaling to its client that the data here is authenticated. It successfully validated the DNSSEC data. Now, invalid DNSSEC data will not be sent to the downstream resolver. Instead, the upstream will send back a serve fail error condition. So if you do a dig of something that is a broken DNSSEC entry, you are not going to get back the data and some flag that says, oh, and by the way, don't use this. You're actually going to get back something that says serve fail, and you're not really going to know why unless you do some debugging. So we will, again, talk about this when we talk about how to debug DNSSEC. The CD is the application signaling that it's going to possibly do the validation itself. We don't want the upstream server to validate. It's free to do so if it wants, but we are going to say, give me the data even if it's bad. That's useful for broken zones, or in the case that we're going to see a little bit later, for doing testing. The DO bit didn't show up in the set of bits that I just showed you. Why is that? Well, because it is in the eDNS header, which is not in the DNS flags field. It's not something that was created back in 1983. It is a flag in the eDNS header that is DNSSEC OK. That means that the client is able to handle the DNSSEC responses. And in addition, it's able to signal that it is able to handle UDP DNS responses larger than 512 bytes. You're actually going to see this in the buffer size. The negotiation of a larger buffer size is going to be very important when we start doing DNSSEC, because a lot of resource records, the responses, are no longer going to fit in 512 bytes because they now contain not only the resource record, but also the signature data as well. So we're going to have much larger data coming back to us. So with that, we are going to close off the new information about how to do zone signing with bind. We will see the easier way to do it in a coming week when we talk about the KASP tool. But you needed to understand what KASP is actually going to be doing under the covers. And what it's going to do for you is all of the steps minus one that we just saw today. The one thing that it does not do is it does not insert the DS record into your parent zone. It doesn't know how to upload that DS record, how to communicate that DS record to your upstream. So that piece is still left out, but all of the other things it's going to do completely automatically. So with that, let's open it up to any questions. And can we have any questions that were asked previously?
So far, all the questions have been in the chat window. If you want to take a look at that, the first one I think you'd seen, it was from Mark asking, why is the algorithm number prepended by zeros? When working with it in bash shell scripts, this is an invalid octal number unless you explicitly tell bash that this is a base 10 number, it strips the leading zero. So how can you deal with those leading zeros when automation?
You really don't want to do a lot of this with bash, at least with the older versions of the scripting, with the older version of the keying material. It's going to be much easier now to use the names of the algorithms that are provided in the keying material. So use RSA SHA-256 instead of 8. I think it was bad. I don't even know why. Well, I mean, other than to make it, an even, that it's always going to be 3 characters long. I agree, it's a pain. And but I also, I think that there should be strong typing in bash. So you should be able to specify that what it is you're reading is a string and not a number. So it shouldn't do that validation of 008 being an octal number. But again, I have no control over any of the above. So the best I can do is tell you, use a better tool set, use a newer version of the bind tools, and we'll move forward from that.
Okay, here's a comment that RFC 8624 recommends EDSA over RSA SHA-256 or RSA SHA-512.
I'm sure that someone much smarter than I wrote that RFC. So if that's, and now one thing that you need to do, make sure that the recommendation actually fits your use case. And I don't know, honestly, what the difference between ECDSA P256, SHA-256. I don't know what the actual difference is there. So again, smarter people than I. So, follow the RFCs and take a look.
Then there's a comment, has anyone successfully gotten network solutions to add a DS record? Unfortunately, that is, that historically has been a problem, not network solutions specifically, but, operators.
Well, I'll add my 2 cents here, and my 2 cents is worth probably less than your 2 cents. But working with network solutions on this has been very painful. All of the other registrars, or the registrars that I've worked with, have been able to figure out in the last 7 years how to go about putting a DS record in place. I don't use network solutions anymore, and this could possibly be one of the very reasons for that, in addition to them being more expensive than all the rest.
Okay, I'm not exactly sure what this question means. From Naven, what permissions should the keys have? Do you know, can you guess?
Yeah, so this is going to be Unix permissions as far as being able to, the visibility of keys. And so the biggest thing here, obviously the .key files are literally put into the zone data. So hiding those is totally unimportant. The .key files, on the other hand, I'm sorry, the .private files, on the other hand, are the private portion of the key. They need to be readable by the DNSSEC-signzone application. And they also, if you are having dynamic zones and you're having bind do the signing for you, then it needs to be readable by the bind process. Now, if you are very, very concerned about your zone data, then this is one of the times that you really want to start considering the use of an HSM or soft HSM, so that you don't have these files just sitting around on your file system. Obviously, anybody with root privileges on a Unix box is going to be able to read these files. So, if somebody breaches your machine, then they are going to possibly, get access to this data. And, unless it's in something like an HSM, then it's going to be very, very visible. I see that the next question is how do non-DNSSEC and DNSSEC servers communicate? There is really no difference between a DNSSEC server and a non-DNSSEC server, other than the fact that some of them are doing validation and some of them are not. Any modern version of bind, even if it is not doing DNSSEC validation, is still going to, make all of the resource records visible. So for example, an authoritative server that is, not for whatever reason, cognizant of DNSSEC, they're still going to serve the RRSIG data, because all it is a different type of data. And bind itself, for the most part, is not really looking at what the data is, it's just serving it. So that's, they're really, and in addition, there really shouldn't be any server that is not at least aware of DNSSEC. You may not be signing your zones and making them visible as a signed zone, but your servers these days, you cannot build bind without the DNSSEC enable option turned on, so it knows how to do DNSSEC. It may just not be, you may not be signing the zones, but bind is aware of DNSSEC.
Well, that's a good lead into another comment that Josh made. ECDSA is a newer algorithm, and when it first came out, there were resolvers that couldn't support it. And there may still be some legacy resolvers that don't support it. And it does actually put a little bit more burden on the resolver, on the validating resolver. And so that may have been a reason that sort of slowed the adoption initially. That's not exactly what he wrote. Wrote was a little bit.
Yeah, so if you sign, if for example, I'm the bleeding edge of doing everything, and I decide to use whatever algorithm number 45 is. Obviously we don't have algorithm 45, but it's something so far in the future that I'm the only one that knows how to sign zones and knows how to validate with them. Well, people are still going to be able to look at my zone data, and even people that are doing DNSSEC validation are still going to be able to see my zone data, but they are not going to get back the AD bit, because when they try to do validation of it, their server, their upstream, not knowing about algorithm 45 is still going to give them back the data, but it's going to say, there was this signature and I just didn't know what to do with it. So, signing something with a future version or a future algorithm that not everyone knows about yet still works, but it does leave your zone open to spoofing, because, your validator obviously isn't doing the right thing with it. It doesn't understand how to do. Yeah, if that made any sense at all. I hope it did.
Yeah, there are a couple of other comments, both from Josh and from Mark, that ECDSA is generally regarded as superior because of the smaller key size, so smaller signatures, and because of that, less potential for amplification.
Right, sure.
And I think that's all of the questions that we have. And I thank everybody who has sent us comments about issues they had joining Zoom today. I did hear from the folks that run Zoom this morning that they were overloaded with all of the people suddenly working from home. So it's possible that this was a load related issue, but it's a little weird. I gather some people were asked to re-register. Some people couldn't join from the browser and had to go download the app. So I'll investigate that and see if we can fix it. I wanted to remind everybody that we are skipping next week. The reason is originally we were planning, Alan was actually going to be giving a presentation in Sweden next week, but obviously that whole thing is called off. But we don't want to change.
Not Sweden. Sweden is still there. It's just that the presentation, the meeting was called off.
Right.
Sweden called off.
Yeah, Sweden hasn't been called up. In any case, we're not changing the schedule at this point because that would confuse more people. So you'll have the next week off from DNSSEC.
Everybody have a wonderful week off, and hope to see you back in 2 weeks. Please do, stay safe, stay healthy, and keep washing your hands. We'll talk to you in a week.
Thank you. Bye-bye.